So you should have been able to get most of your terms written down from section 1.6 regarding polygons, concave, convex, regular, and how to name the different polygons. So I'm going to go over a few specifics on those. When you wrote down your definition of polygons, you know that it's a closed figure. You know that the sides have to meet at the endpoints. So I've got some pictures of some examples of polygons and then non-polygons. Notice each of these are closed figures. The sides meet endpoint to endpoint. If we look down here, we've got some differences. Up here, there's curvature at the top and on the bottom. You can't have any curves when it's a closed figure, when it's a polygon. Here, this isn't closed. The sides don't meet, so that can't be a polygon. Here, the way the sides cross, it's almost like you have two polygons connected together. Well, that can't be a polygon alone by itself. Here, the side is extended, which can't happen either. It has to, each of the endpoints have to meet end to end. With concave and convex, the figures where we're going to be finding measures, those are all going to be convex. And the way you can tell the difference between convex and concave is essentially if you were to draw a line from one vertex to the other, if you were to extend it, then when it's convex, that line is not going to extend into the inside of the polygon at all. If I do that on the concave, notice that red line, it goes inside. Same here. And the same here. That's what makes those concave rather than convex. It's like they're caving in. They have interior points. You did an activity after you wrote down your notes where you had to draw the triangles that are formed from the diagonals inside of polygons. Through this, you should have been able to find the formula for finding the sum of all the interior angles of a polygon. So I'm going to go over that formula now as well as some other formulas to find various information. You should have found the formula was 180 degrees times n minus 2, n being the number of sides. Each of your figures, you should have found that you had 2 less triangles than the number of sides when you drew all of those. For example, in a quadrilateral, there are 4 sides. You were able to draw 2 triangles. In a pentagon, 5 sides, 3 triangles. We know that the sum of the interior angles of a triangle is 180 degrees, so you can just figure out how many triangles you have in the polygon, and that's how you find the sum of all the interior angles of a polygon. So if we look at an example, I'm going to find the sum of the measures of the interior angles of an octagon. An octagon has 8 sides, so I'm just going to plug that into the formula. 180 times 8 minus 2. Remember, you have to do parentheses first. 180 times 6, and I get 1080 degrees for the sum of the interior angles. You also have exterior angles in a polygon. Remember from when we did triangles, when you extend the side of a polygon, you make an exterior angle. The exterior angles, they are always going to have the same sum. So there's no formula for finding the sum of the exterior angles. Think about, as you go around the polygon, you're making a circle. Well, how many degrees in a circle? 360. So the sum is always 360 degrees, regardless of how many sides. Remember that exterior angle is on the outside right here. This is an example of an interior angle. This is a polygon with all the exterior angles drawn. If I add up each one of those angles, I just set it equal to 360 degrees. That will always, always be the case. So as you're going to see, you're going to have all kinds of different problems. They're going to ask you to find the sum. They might ask you to find one angle. They might ask you to find the number of sides. So I'm going to try to give you an example of each of those. Sometime you might have a problem where it says find one of the measures of the interior angles of a regular polygon. Well, to find one of the interior angles, it has to be a regular polygon because I need to know that they're all the same in order to find one. So I know how to find the sum, and if I can find the sum and I know how many sides, then I can find just one of those angles. So I'm going to find the sum, which is 180 times n minus 2, and then I'm just going to divide it by however many sides I have, because however many sides I have, then that's how many angles I have. So we'll look at an example. If I want to find one interior angle of a regular decagon, well, a decagon has 10 sides, so I'm going to start by finding by finding the sum of all those interior angles. So 180 times 8, which is 1440. Well, I know there are 10 angles inside of that polygon, so I divide that by 10. It tells me each interior angle is 144 degrees. And just remember, it has to be regular to be able to do this. Another example, finding the number of sides of a regular polygon given the sum. With this, we're going to work backwards with our formula. I know that my formula is 180 times n minus 2, and that gives me the sum. Well, if they give me the sum, then I can substitute my values in and solve for n. So I have an example where the sum of a polygon is 2700. So I'm going to do 180 times n minus 2 equals 2700. I want to divide both sides by 180. And then to get n by itself, I want to add 2. So that tells me I have a 17-sided figure. If we wanted to classify that, we would call it a 17gon. Next example, find one of the measures of the exterior angles of a regular polygon. Remember before we said that the sum of the exterior angles never changes. It's always 360 degrees. So if I know the type of figure it is, then to find one of the angles, I just take 360 and divide it by the number of sides, and that gives me one exterior angle. Finding the number of sides of a regular polygon given one interior angle. Well, there are lots of different ways to do this one. You know, I generally like to go for the most straightforward way, so that's what I'm going to show you. To me, it's always easiest to use the exterior angle as much as I can because I don't have to find that internal sum. So if I know the interior angle, I can find the exterior angle because they are a linear pair. Exterior plus the interior equals 180. And if I know the exterior, I divide 360 by the exterior angle, and it gives me how many sides. So let's just sort of break this down with an example. Find the number of sides of a regular polygon given one interior angle of 160 degrees. So if my interior is 160, I know my exterior is 20. If I take 360 divided by 20, I get 18. That tells me there are 18 exterior angles, which means there are 18 sides to this polygon. Some examples you may encounter, one like this. I shouldn't say may encounter. You will have problems like this. You want to ask yourself, what kind of angles do I have? Do I have the exterior or do I have interior? That's the first question you always want to ask. These are exterior. What do we know the sum of all the exterior angles is? 360. So I'm going to take each piece and add it together and set it equal to 360, and I have an equation to solve. This one, these are interior angles. Well, interior angle sum, is it the same every time? No. So I need to count up the number of sides, use my formula, n minus 2 times 180, to find the sum, and then I add each of these, and I set it equal to that sum. You're going to have other types of examples. We will do lots of practice, save all your questions, and we will continue after this. If you need to go back and watch this video, know that it'll be on Edline. You can go back and watch it as you do your work if that helps. And we'll continue to 6-2 tomorrow.